Okay, and so what is a logarithm? That's the question here. And so if we can think about it, if we were to plug this into a calculator, log of some number, we'll call it x. Okay, the logs we're going to be talking about are going to be base 10. I'll explain what that means in a little bit. It's going to give us some value, y. So we plug in, log of 10, it'll give us some value. And so what it's asking us, what this means, basically 10 to the y will give us x. So what it's saying is, when we plug in a number, what exponent do we have to raise 10 to in order to get this number? Okay, so for example, if we were trying to take the log of 100, okay, what that's saying is 10 to what power will be equal to 100? And well, 100 is 10 squared, so the log of 100 will give us a value of 2. Okay, that's how we use logs, and if we get our H plus concentration, we can figure out the pH. It's going to be negative log of H plus. But why a logarithmic scale? And so we see logarithmic scales in things where we have a big range of numbers. And so you can see here, going from pH of 0 to pH of 14, we're talking about concentrations of 1 times 10 to the 14th, or excuse me, 1 times 10 to the negative 14th to 1. Okay, and so there's a big range. And so what we do is, by putting this on the logarithmic scale, you can see each one we go down, so going from 0 to 1. Okay, in terms of concentration, we've changed it by a power of 10. Okay, each time we go up 1 in terms of our pH, anytime we change 1 in our pH, so from say pH of 7 to pH of 6, we're gonna go 10 times. Okay, and so this is similar to something like the Richter scale, where if you go a magnitude 7 earthquake is 10 times bigger than a magnitude 6. Okay, and so it just makes it something that is a little more usable. So instead of having an arbitrary random 1 times 10 to the negative 7th as your concentration for neutral, now you have pH of 7. That's easy. pH 7, compare that to pH of 4, and life is good. Okay, and we'll see how this works in a second. So for example, pH, let's say we're trying to find our pH of move that over a little bit. Okay, let's say we're trying to find our pH of a 0.1 molar HCl solution. Okay, and another thing we can look at is our pOH. So if we're talking about 0.1 molar HCl, life is going to be easy. So HCl is a strong acid, and what we mean by a strong acid is that it's going to completely dissociate. So every little bit of HCl you have is going to split up into H plus and Cl minus. So you have it in solution, you really don't have HCl, you have H plus and Cl minus. So pH, if we're trying to find the negative log of concentration H plus, it's going to be 0.1 molar for our H plus. So negative log of 0.1. Okay, and so in this case our pH would be equal to 1. Okay, we'll come back to pOH in a second, but pOH is just going to be negative log concentration of OH minus. Okay, and so we need to know concentration of OH minus to do that. Going back, if we're talking about pure water, so just distilled water, where we had an H plus concentration of 1 times 10 to the negative 7th, pH would be equal to 7. pOH in this case, so again, the H plus concentration, the OH minus concentration in pure water was the same, so taking the negative log of the same number is also 7. Okay, and what we can see, if we know the concentration H plus, we know the concentration OH minus by comparing it to Kw. So Kw, the 1 times 10 negative 14th, divided by this H plus concentration of 0.1, is going to be equal to our concentration of OH minus here. And so concentration OH minus is 1 times 10 to the negative 13th. And so if we take the negative log of that, we're going to get a pOH that's equal to 13.